Several of you seem to be having difficulty with the application style problems that are in lesson 5.2, where you're asked to use the right triangle relationships to solve an application problem. So I've pulled several of those from Newton and am going to work through them here in this video. So the first one says a vertical pole 40 feet tall cast a shadow onto the ground, and the angle of elevation from the tip of the shadow on the ground to the top of the pole is 67 degrees. Use the dimensions given to find the length of the shadow, A, in feet. Do not include the units in your answer and round your answer to the nearest tenth. Guys, to solve these problems, you really need to draw a picture, and they try to give you enough information to do that. We know that it's ultimately going to be a right triangle because that's what you have to have in order to work through these problems. So initially here in this problem, they tell us we have a vertical pole. So we can assume, since the pole is vertical, that that pole creates a right angle with the ground. It also tells us that that pole cast a shadow, and that shadow is A, and that's what we're ultimately looking for. It also tells us that from the tip of the shadow, so here's the tip of the shadow on the ground to the top of the pole, the angle is 67 degrees. Okay, now it talks about this angle of elevation. Typically you hear two phrases: angle of elevation and also angle of depression. Elevation has in the context, implies that you're looking up at something. Angle of depression implies you're looking down. So from the tip of the shadow, the angle of elevation is 67 degrees. And so we have at that point, we know that the pole is 40 feet tall because it says a vertical pole. The fact that it's vertical means that we get the right angle, and it's 40 feet tall, casting the shadow that creates from the tip of the shadow to the top of the pole is a 67 degree angle. So looking at the information that I have here, I have an angle. With respect to that 67 degree angle, I know the value of the opposite side, and I am looking for the adjacent side. So in my mind, that means that I'm thinking opposite and adjacent. I'm going to use tangent because the tangent of an angle is opposite over adjacent. So using that particular relationship, then I'm going to substitute my information. So I would have the tangent of 67 degrees is the opposite divided by the adjacent, which is what we're looking for. So then I need to do some algebra, some basic math, to solve this equation for A. So I'm first going to multiply both sides by A. I have A times the tangent of 67 degrees equals 40. I am trying to solve for A, so I'm then going to divide both sides by the tangent of 67 degrees. Now, typically when I'm doing these right triangle problems, I want to use primarily either sine, cosine, or tangent. And the reason that I want to do that is because of the calculator button. So ultimately this is A equals 40 divided by the tangent of 67 degrees. So then I need to go out to my calculator, and a couple of things. One, you want to check the mode on your calculator by pressing the button that says mode, and you want to make sure that you're in degree mode because the measurement of the angle was given to you in degrees, which is the third line there. Degree is highlighted in black, which shows me that I'm in that mode. Also, as I commented, you want to use sine, cosine, and tangent because you have those buttons on the calculator. Okay, if you use secant, cosecant, or cotangent, it gets a little tricky. So it just makes it easier. So I'm going to type this in, 40 divided by the tangent of the 67-degree angle, and hit enter. And it asks me in the question, I get 16.97899. It asks me to round to the nearest tenth, which is 1 decimal place. So looking at this, let me bring it over here to our paper. We get 16.97, but we're asked to round to the nearest tenth, which is 1 decimal place. So if I want 1 decimal place, I have a 7 next door. The 7's going to bump the 9, but the 9 then is going to bump the 6. So this ultimately rounds to the nearest tenth as 17. Now it doesn't want you to include the units, but that's 17 feet. So what we have determined is that the length of this shadow is 17 feet. And that would be our answer. Okay, moving on to the next question. It says, how long of a ladder is needed to reach a windowsill 50 feet above the ground if the ladder rests against the building, making an angle of 75 degrees with the ground? Round your answer to the nearest foot or to the nearest whole number and do not include the units. So again, if we think about this, they're thinking about perhaps like a house. And on this house, you have a window, and that windowsill, it says, is 50 feet from the ground. Okay, we can assume that the side of the house creates a right angle with the ground, and that windowsill between the ground and the windowsill is 50 feet, is 50 feet off of the ground. We're going to lean a ladder against the wall to reach the windowsill. Okay, so here's our ladder. I'm not very artistic, but hopefully you get the idea. There's your ladder. And the last thing that it tells us is that the ladder rests against the building, making a 75-degree angle with the ground. So the 75-degree angle is here because it says with the ground. So there's 75 degrees right here. And we want to know how long of a ladder do we need. So in this case, we're looking for the length of the ladder, which is x. So then again, I've got to decide, should I use sine, cosine, or tangent? So with respect to the angle of 75 degrees, I know the opposite side, and I'm looking for the hypotenuse. So opposite and hypotenuse hopefully makes you think of sine. Sine is opposite over hypotenuse. So I'm going to use that formula. I'm going to plug in. So the sine of 75 degrees is the opposite over the hypotenuse, which is the value that I'm looking for. So again, if I'm solving for x, I'm going to multiply by x on both sides. So I have x times the sine of 75 degrees equals 50. And again, I'm trying to solve for x, so I'm going to divide by sine of 75 degrees. So x equals 50 divided by the sine of 75 degrees. And again, I'm going to go out to my calculator. I've already confirmed that it's in degree mode, so I'm going to have 50 divided by the sine of 75, enter, and I get 51.76. Okay, so my answer is 51.7, but it asked me to round to the nearest whole number. So I have a 7, which is going to bump, so it becomes 52 feet. And again, they ask you you don't include the units, but the length of the ladder would have to be at least a 52-foot ladder in order to reach the windowsill. One thing that might help you as you're thinking about solving these right triangle problems, even in the context of the applications, is that the hypotenuse of a right triangle is always the longest side. So the fact that I get an answer of 52 is reasonable because it needs to be longer than the 50 foot from the windowsill. Okay, here's a third one. Again, we're going to read it and then try to sketch a picture. It says David is looking out of his office window 40 feet across the street from him. He determines that the angle of elevation to the top of the building is 62 degrees and the angle of depression to the bottom of the building is 55 degrees. How tall to the nearest foot is the office building? Okay, so let's see what we got here. It says David is looking out his window at the office building. Okay, so here's David, and he's looking out the window. Here's his window, and it says the office building is 40 feet across the street from him. So 40 feet, and we have to assume that's straight across to the office building. Which I would to cross from him. Okay, so you got the office building. It says then he's able to determine that the angle of elevation, which implies he's looking up, to the top of the building is 62 degrees. He determines that the angle of depression to the bottom of the building is 55 degrees. So you almost have two pieces in one here, okay, because you can assume it says David is looking out his window and it's across the street from him. So we can assume that he's looking straight, okay, because it says away across the street. Okay, so his line of sight initially would be straight ahead. So that's your 90-degree angle. So we know that it's 40 feet across. So you have one triangle. See if I can highlight it for you. For the angle of elevation. But you have a second triangle for the angle of depression. Okay, so you're actually going to have two values here. Okay, so you can call it whatever you want. If we call it, you have x1 and x2. It's like you have two different measurements that you're going to have to find. Okay, so if I deal with the yellow triangle first, okay, so let's make this a little yellow mark so we know that we're dealing with the yellow. And I know the 62-degree angle of elevation, 40 feet across, and I'm looking for the opposite. So I know the adjacent and I know the opposite. So that lets me know I want to do the tangent of the angle, which is opposite over adjacent. So I would have the tangent of 62 degrees is the opposite, which is x1, over the adjacent, which is 40. And then I have to solve that for x1. So I'm going to multiply both sides by 40. So I'm going to have x1 equals 40 times the tangent of 62 degrees. So for the yellow triangle, I'm going out to my to my calculator. 40 times the tangent of 62 degrees, which gives me 75.229. I'm going to round it for now. Okay, so I have 75.229. Then we have to do the turquoise triangle. Whoops, kind of got wild there, didn't I? Okay, so now we're looking at that triangle. And again, we know the adjacent and we're looking for the opposite. So again, we can use tangent. We're going to have tangent of 55 degrees equals x2 times 40, which gives me x2. Whoops, skipped a step there. Sorry, getting carried away. Multiply both sides by 40, just like we did before. So we get x2 equals 40 times the tangent of 55 degrees. So I have 40 times the tangent of 55 degrees, which gives me 57.126. Okay, so I get 57.126. So what I've done, and it may not be as obvious, okay, I found basically the top half of the office building to be 75.229. I found the bottom of the building to be 57.126. So to get the height of the entire building as a single number, I have to add those two values together. So 75.229 plus 57.126 is going to give me 132.3. When I round that to the nearest whole, that gives me 132 feet. So when we put those two together, from the top of the building to the bottom of the building, we get 132 feet. Okay, you don't have to type in the units, but that gives you the entire height of the building. So it's kind of like two problems in one. Okay, I believe I've got one more example here. I tried to do a nice variety. It says you are standing 42 feet away from a tree. Your line of sight is 5 feet from the ground. If you measure the angle of elevation to the top of the tree to be 43 degrees, how tall is the tree? Okay, so you're standing here. Here's you. Kind of disproportionate, but there's you. It says your line of sight is 5 feet off the ground. I mean, your head is not literally on the ground. So they're assuming that line of sight is 5 feet off the ground. And it tells us that you're standing 42 feet away from a tree. So then we got a tree. Okay, your line of sight is 5 feet off the ground. And it says if you measure the angle of elevation from your line of sight to be 43 degrees. Okay, so your line of sight is like the horizon. Okay, so this angle here between your line of sight is 43 degrees. Okay, but now you need to remember that that's already 5 feet off the ground. So there's 5 feet of the tree that you're not actually going to calculate, because with your line of sight, okay, to the top of the tree, and we drop an imaginary vertical there, and you can assume the tree is vertical. It may or may not be with the ground. Okay, so you're going to focus on this triangle right here. And again, thinking about the pieces that you know, okay, I need to find, I'm ultimately looking for the height of the tree. Well, I've got this 5 feet, and I'm looking for from that line of sight to the top of the tree. So there's my X. And I know the angle, and I know I'm 42 feet from the tree. So I know the adjacent. It might help you to realize that you know that this is 42 feet. So you got the adjacent, and I'm looking for the opposite. So again, opposite and adjacent, I'd have the tangent of theta is opposite over adjacent, which gives me the tangent of 43 degrees is the opposite over adjacent. I'm going to solve for x, multiply by 42 on either side. So I have 42 times the tangent of 43 degrees equals x. So out to my calculator, 42 times the tangent of 43 degrees. I get 39.165. And how did it ask me to round? To the nearest tenth. So we got 39, 39.16, rounding to the nearest tenth, which is 1 decimal place. Okay, the 6 will bump the 1. So my answer is 39.2 feet. But that measures from your line of sight to the top of the tree. You have to also include the 5 feet that you were off the ground. So that's not actually my answer. My answer is ultimately 39.2 plus the 5 feet for being off the ground, which is 44.2. So my answer, the tree, is actually 44.2 feet tall. Okay, so be careful. It's going to help you if you'll draw the picture and they try to describe it. Literally walk through it word for word.